Question for today, that is maximum product of two digits. The question says you are given with a positive integer n. Written the maximum product of any two digits in n. Note, you may use the same digit twice if it appears more than once in n. Looking at the examples, this question is actually an easy level question, so we can analyze how we get the answer through the examples itself. So we are given with a number of two digits and the output is 3. How do we get it as 3? That's basically you have to multiply any two digits. Here we are given with only two digits, so we multiply both of the digits and we get the answer as 3. We written it out. Even here it's the same case. You have two digit number, you multiply both the digits and get 4. But here it's a different case. We have 3-digit number and we'll be multiplying two digits at a time in order to get the maximum product. So first you multiply 1 with 2, you get the answer as 2. 1 with 4 and get the answer as 4. And 2 into 4 gives us 8, which is the maximum product over here. It's 8. So you written the answer as 8. I hope the question is clear. Now let's try to code this out. But yeah, before getting into coding part, we will just have a discussion about the approach of solving the problem. For this problem, we will need two variables, that is the highest digit and the second highest digit out of the given number. So because that's a common knowledge, right? When you multiply the highest two digits, then you'll of course get the highest value, maximum product. So you'll be assigning both the variables to 0 and then you will have a while loop running until n becomes 0 and you'll find out a digit. Then we'll find the highest digit out from the number given and the second highest digit, and then we'll be multiplying these two numbers. We'll get our answer. Okay, let's start coding. Let me initially take the first number as highest equal to 0 and int second highest equal to 0. Then we'll run a while loop until n is greater than 0. Then we need digit, which is equal to n mod 10. Okay, now we have to find the highest digit. So if the digit is greater than highest, then highest is equal to digit. Okay, now if the digit is not greater than highest, better to write if else. No, it is must, because if you don't write the condition, it can take any other number, right? Else if digit is greater than second highest, then second highest is equal to digit. Here we have both our important digits. Then we need to update the while loop for each and every iteration. This is how it will work. And then we'll written highest into second highest. Okay, this is it. Oh, yeah, the variable typo error. Okay, now it should work. अरे यार. Okay, what's the error now? Why is it showing as 0? Highest is calculated properly, second highest is also calculated properly. Mm, we forgot to write one condition. That is, second highest is equal to highest. That's because, see, understand. So here you found a digit which is higher than the highest. So that digit will go to the highest thing. But what about the value that is within the highest? Right? That is the second highest. That's why you need to write this line. Yep. Explaining why did we get 0 for this case is because, see, first of all, we had 1 in the first place of digits. So it compared 1 is greater than highest, which is 0, which is true. So this line was in there, right? Our highest had 1. Next iteration, we have 3 as our digit. So 3 is greater than 1, which is true. We had 3 in the highest position. But this didn't work because if else, that's it, right? So here what happened is highest is 3, 3 into 0 is 0. That's why we got the answer as 0. I hope the explanation is correct. It's like what, that's how it works. So this condition is really very important because at a time only one condition works, right? Like if or if else. That's why. Now, talking about the time complexity, it's big O of log 10 yen. That's because our loop divides yen by 10 in every iteration. The total number of steps is exactly equal to the count of the digits in the number. And the space complexity is obviously big O of 1 because it executes entirely in place. Only few primitive integers like highest and second highest is being used. So the space complexity becomes big O of 1. Thank you.